Welcome to the solutions video for our January 13th, 2025 assessment. Okay, it's loading up here. Oh, and I see it is still organized as I do when I'm creating it. So, here we go. We want to convert this equation into slope point form using any point other than the y-intercept. So I need to see that you found a point here. Now, slope point form. Our slope is still negative 17 over 12. We need any point whatsoever. So, in y equals negative 17 over 12x plus 3 over 7. I'm going to pick x as 12 over 7. Because when we're doing slope point form, we can pick any point whatsoever, totally up to us. The advantage here, if we have negative 17 over 12 times 12 over 7 plus 3 over 7, now our 12s cancel, and we have a negative 17 and 3 in our numerators over a common denominator of 7. So that gives us y is negative 14 over 7. I did that just to build the common denominator. I didn't realize the random generation meant that actually simplifies to negative 2. So putting this in slope point form, we'd have y plus 2, because it's y minus 1 equals m. 17 over 12. And x minus x1. And that fraction, we picked 12 to cancel the denominator we have, and 7 to match the denominator from the other term. Now putting it into standard form, for that, let's change color here. So y is negative 17 over 12x plus 3 over 7. Standard form has a positive coefficient of x, no denominators, no common factors other than 1. It's our ax plus by equals c form. Let's start multiplying everything by 12. There's no cancellations with the 7. We have this. Now, let's multiply everything by the 7. Oh, that should have been a y. I missed that last time. 84y. Now, 17 times 7. We have a 49. Carry the 4. So we have a negative 119x plus 36. Now, yes, these are both even. 119 is odd. And in fact, it might even be prime. It is not divisible by 2, not by 3, because these add up to 11. Not divisible by 5. It doesn't end in a 0 or a 1. Oh, right, it's not prime. It's 7 times 17. That's how we built it. Well, 12 does not have any factors of 7 or 17. 36 does not either. This is not going to simplify. No cancellations. We just have to move our x so it's positive. So we move it to the left-hand side. And we get 119x plus 84y equals 36. So there we go. 119x plus 84y is 36. These are done. Our next, we have this linear relation. We have to write it in our 3 forms. So standard, slope intercept, and slope point given a very specific point. So we have to start by collecting our like terms. Looks like we're going to have, to begin with, 19x And for our y's, there's a -9 and a +8. So that's just minus y. For the constants, we have a 5 on the left, 20 on the right. So that equals 15. So there we go. 19x minus y equals 15 is our standard form. Slope-intercept form, we can isolate y. We take our 19x minus y, move the y to the right and the 15 to the left. We'll have y is 19x minus 15. Now for our slope point form, we know our slope is 19. We need to find the point, and to get full credit, we have to not have k in the answer, but have an exact value of k. Well, 7 times 19, that's what we need, 7 times 19 minus 15. So 7 times 19, 7 times 20 would be 140. So it's 7 less than that. It should be 113. Right, 19 times 7. Well, 7 times 9 is 63. Yes, 133. That is consistent here. So 133 minus 15 is 118. So that's our points, 7 and 118. So then y minus 118 equals 19. And then I wanted brackets there. X minus 7. Okay. And in this case, we actually can confirm, at least we can confirm this point. If we're doing it with our graphing calculators, they can only graph y equals. So once we turn it into y equals 19x minus 15, well, now we have our graph. If we take x equals 7, there's this vertical line. And we could track the intersection. Double check that, yes, it does happen at y equals 118. Okay. So that is our RF6. Now RF5. We have, it looks like a lot of questions. As I warned you guys, we have finding the key points worth partial marks each, one for each of the 3 types. So here we have 13x minus 14y equals 17. We need the slope. So 13x minus 14y is 17. That tells us that 14y is a negative 13x plus 17. Y is a negative 13 over 14 x plus 17 over 14. So here's our slope, negative 13 over 14. Negative 13 over 14. The y-intercept, we can get right off here. We see that it's 17 over 14. We can also double check it by letting x equal 0, and now we have a different sign. Did I mess up a sign someplace? Because if we let x equal 0, y is a negative 17 over 14. And yet somehow when I did this, it's coming out as a positive 17 over 14. So let me double check where that difference is. So 13x minus 14y. Actually, if x and y have different values, these should be positive. That's where I'm messing up someplace. Oh, it's because that sign never should have changed. That's a big part of our difference. So these should be positives. Okay. So the slope here is not a negative 13 over 14. It's a positive 13 over 14. The y-intercept should be a negative 17 over 14. When x is 0, it's always good to go back to the original question. So if we did make a mistake, as I did here, building the problem, right, I changed the signs on the y. I shouldn't have changed the sign on x, but I should have changed the sign on the constant when it moves to the other side. So this y-intercept should be negative. That's where it got messed up. Okay, so we do the sanity check, we figure that out. Our x-intercept, if we let y equal 0, our x is 17 over 13. Now, if x is negative 3, what value does k have? We could substitute x into the 13x minus 14y. In this case, it's x equals negative 3. We can even take it in our graphing calculator if we've turned this into slope-intercept form and substitute. When x is negative 3, y is negative 4. Again, substituting y equals negative 18. Then isolating our x, we see it is a repeating decimal of some kind. So y is a negative 18. Going back to that 13x minus 14y. (13x minus 14y) equals 17. So x is, if we add 14y to both sides and divide by 13, that's what we have. Our value of x here, or of y here, is negative 18. 14 times negative 18 plus 17 over 13. That did not work out. Now 14 times 18, mental math, this is 16 minus 2 times 16 plus 2. Difference of perfect squares says that's 16 squared minus 4 squared. 18 is negative, so we have a negative 252. 16 squared minus 2 squared. 256 minus 4. And then 252 or negative 252 and 17. That should be negative 235 over 13 if I have done that mental math correctly. 13 is prime. So if 13 was a factor, it would reduce to a whole number. 260 is 13 times 20. So 234 would be multiple of 13. 235 is not. So we should have negative 235. Okay. I did get an error message from this. That's the issue I'm seeing here. So I did change yours after generating it for the students to add one more digit to this. I think that box goes up to 8 now, and I see this is why. We are a little bit short, so I'll be hand scoring those just to be sure. All right, now, which of these graphs has a domain of x equals 4? That's our red one, which is multiple choice A. Range y equals 4. Every possible y value is 4. That's our blue one. These domain and range questions are half a mark each. Which has a y-intercept of negative 3? Well, that's green. And an x-intercept of 7. That would be our orange. That's C. So now another one of these. This time it's slope-intercept form. So our slope is 2. Our y-intercept is 5. We could read those off. When y is 0, x is negative 5 over 2. Now the value of k, if you have negative 13 over 5, when x is a negative 13 over 5. Do this algebraically. So x is negative 13 over 5. We could substitute that in. And either way, the point of intersection is at y equals negative 1 over 5. If y is 9, then x is 2. Makes sense. 4 plus 5. Now, this one, yeah, we're going to have a slope of 2. The y-intercept, when x is 0, we have a negative 38 on the right. We add 13, we get negative 25. The x-intercept, when y is 0, negative 13 over 2 plus 19 is a negative 13 over 2 plus 38 over 2. 38 minus 13. So that would be 25 over 2. When x equals 15, the bracket is 15 minus 19, or negative 4, times 2 is a negative 8, plus 13 should give us y is 5. And number 15, if y is 1, this is negative 12 divided by 2 to make negative 6. Add 19, we are at a positive 13. So that finishes our RF5 questions. All right, and our next one. The following table of values represents a linear function or linear relation. What is the value of k? We're going up by 8 over 4 each time. We're adding 2 each time. 49 plus 8 is 57. Okay, before we get too far, you might have heard me coughing. I just went back to double check how we're doing relative to the answer key. And it's disagreeing with numeric response 9 and 10. So I'm going to double back there. That's our x equals, or the y equals 2x plus 5. So we got a negative 1/5 and a 2. And the answer key has them the other way around. So I've keyed those backwards. I will have to correct that. Because when x is 2, y is definitely 9. Okay. So I will have to reverse those in RF5. Okay. So, how can we determine if a table of values represents a linear relation? So the ratio of consecutive values of the dependent variable is constant. That That is tempting but incorrect. This only works if your y-intercept is 0. If you have x plus 5, that is linear. And when x is 1, y is 6. When x is 2, y is 7. X is 3, y is 8. 7 over 6 is not the same as 8 over 7. So that's not the case. The difference between consecutive values, yeah, that's where y1 minus y, or y2 minus y1 is constant as long as x2 minus x1 is constant. So that is the correct one. So every time we add 1 to x, we add the same amount to y, whatever that is. We don't deal with the product of of consecutive x values, and the difference with consecutive x, well, we're calling them consecutive, so it's always going to be 1. But that is true of every function. I could give you something that curves in all sorts of crazy ways. But if you're checking x equals 1, x equals 2, x equals 3, you're always going to have x equals 1, x equals 2, x equals 3. So which form of an equation represents a linear relation? That is y equals mx plus b. It is not the quadratic, it is not the exponential, and it's not the reciprocal function. So which best describes a linear relation? Well, it will have a specific pattern. It will not curve. So it's a constant rate of change. The variable rate of change is the only other contender there, but that would not be linear if the rate of change of the slope is variable. So how do we identify independent and dependent variables in a given context? Well, independent is not always time. Dependent is not always distance. The independent one is the one you change. And then the dependent one changes in response. All right, so moving on here. Given f of x equals 2x plus 5, find f of 25. 2 times 25 is 50 plus 5, 55. So now find g of negative 23. 2 times a negative 23 squared minus 5 times a negative 23 plus 7. So I'm going to pull out the calculator for that. So negative 23 squared minus 5 times a negative 23 plus 7. That's 1180. H of 7, when x equals 7, this is 5 over 7. Now, given u of v is 5v minus 7, find the v when u is 48. So it's 48 equals 5v minus 7. That means 55 equals 5v. V is 11. It's like we're finding the x value given the y. Here, given the x, what is this? Negative 3 over 4 plus 1 is a 1 over 4. So there's our f of x. Right. So, written as an entire radical, 5 root 3 is the square root of what? We square the 5, multiply it by the 3 to get 75. Now here, 1512. We want to do the prime factorization of 1512. So, 1512. If we divide it by 2, we get 756. Divide that by 2. 2 goes into 7 3 times. It goes into 15 7 times. It goes into 16 8 times. Another division by 2, that's 1 8 9. No longer even. We're done with the 2's. It's divisible by 3. Goes into that 63 times. 21. And 7. So we have 2 3 times, 3 2's, 3 3's, 1 7. So that's 2 to the 3, 3 to the 3, 7 to the 1. Next up, greatest common factor of these two numbers. So here we actually have our calculator functions that can help us out. Greatest common factor of 168 and 288 is 24. So this radical in simplest form. All right, so it is going to be a cube. Now 216 is 6 cubed. So that 6 has to come out of the cube root. So it has to be a multiple of 6. There won't be enough 6s left to hit 36. It's one of these first two. But when we divide 2,160 by 216, we're left with 10. Alternatively, because it's multiple choice, we could cube the 6, multiply by 10. Doesn't match our question. We could run it backwards, unfortunately, when it's multiple choice. I say, unfortunately, it's great for you guys. It's unfortunate for the teacher because we may not be assessing the skill we want to assess. Okay. And these, again, the calculator can help us find the least common multiple. In this case, it's 810. So now we want to put these in ascending order. So 3 root 18 is roughly 12.7279. 2 root 30 is roughly 10.95. So we have to have the 2 root 30 prior to the 3 root 18. So we've eliminated B. Now the cube root of 84 is a 4.37. So that is the lowest of these three. So that puts us in A and C. D is eliminated because the cube root of 84 comes after 2 root 30. Finally, 4 square root of 8 is roughly 11.33. So that's got to be the third one. So by process of elimination, right, we figured out the decimal approximations, that's C. Another trick we could do. We have square roots and cube roots. The least common multiple of 2 and 3 is 6. We could put each of these in our calculator and then raise it to exponent 6. And that might give us 4,251,528 for our 3 root 18. 2 root 30 to the 6 is 1,728,000. So if we take them each to the 6, we can sort those results. And they'll all be whole numbers, easier for the calculator to differentiate. All right, so if we want to write these in ascending order, least to greatest, we have to start with our negatives. Negative 5 over 9. 5 over 9 is a proper fraction. It'll be between 0 and negative 1. 4 is between negative 1 and negative 2. So we're starting with 4. Then we're going to 1, because that's the other negative. There's only one that starts that way. We could double check that 2 is greater than 3, but that's the way it has to be. The irrational number here. Now this one at first looks irrational. There's no ... at the end, so it does terminate after a large number of decimal places. We take the square root of 169, we get 13. This is similar. By process of elimination, this appears to be it. 16 plus 169 is 185, which is not a perfect square. Oh, I missed one. I didn't realize it had loaded there. So which of the following is irrational? Looking at these, we have 3 that have the ellipses at the end. Can't be B, that's terminating. A seems to repeat 162, 162, 162. C starts off with a 2, 5 and then goes 6, 7, 6, 7, 6. But D, 111, 112, 113, that's a pattern but not a repetition. So that one is not rational. Now, estimate the approximate value of the cube root of 20th, or 20 to the nearest 0.25. So if we take the cube root of 20, we're doing an approximation, so we can pull that in our calculators. Comes out at 2.7144. That's roughly 2.75. All right, now these missing exponents. Exponent rules say if you have an exponent to an exponent, you multiply them together. So if 6 times m is 0, m is 0. Now, we have, so two students who simplified correctly. We have the question equals the answer. Which two are they? Well, the first one, negative 7 times 4 is negative 28. Multiplying variables, we add the exponents. 5 plus 3 is 8, and 1 plus 8 is 9. So student 1 appears to have done it correctly. Student 2 does as well. 3 to the 4 is 81. 7 times 4 is 28. Let's double check that we're not missing something. Student 3, 6 over 8 is 2, but x to the 8 over x to the 2, we don't divide those exponents, we subtract. It should be x to the 6. Student 4, this is not the exponent of an exponent, it's 2 x's. If we write this out longhand, we'll have 11 x's there. They multiplied the 5 and the 6 instead of adding them, so 4 is incorrect. Now here, more written response. Explain why each of the following is true. This is a result of the division rule. We've done the notes in class. If you have x to the a over x to the b, that is x to the a minus b. You put that in brackets. So if we take this where one of the terms is 0, this term comes out of it. We also know that an exponent of an exponent works. So if we have a or x to the 1 over n, so I'm meant to open that bracket, and raise that to the n, we get x to the 1. Now, if we have the nth root of x to the n, that's also x to the 1. So if the two are equal, right, then the terms in brackets must be equal. We still have something in brackets, exponent n equals x to the 1. It can only be true if they're the same. Now in this case, m minus a negative 4 is 10. So m plus 4 is 10. M has to be 6. All right. Now here we're multiplying out this product. X plus 6 times x plus 9. I put my stylus down somewhere. Give me a moment while I pause. All right, found the stylus. I also took a moment to go back and check our results. And there is one that we missed, so I'm just going to jump back to where it was. Numeric response 21. I treated this as x equals 4, but this is y equals 4, not x equals 4. So if we have 4 equals negative 3 over x plus 1, subtract 1 from both sides, 3 equals negative 3 over x. Then that means x is negative 1. All right, so that should clear that up. Now we'll jump ahead here. X plus 6 times x plus 9. So that's x squared plus 6x plus 9x plus 54. X squared plus 15x plus 54. So here our terms are 15 and 54. Similar problem here. This time we're multiplying out to find a, b, and c. So we have 3x plus 5 and 4x plus 23. So 3x plus 5 and 4x plus 23. 3x times 4x, 12x squared. 5 times 4 is 20. 3 times 23 is 69x. And 5 times 23, we have 5 times 20 is 100, plus 5 times 3 is 15. So that's 115. Collecting all of our like terms, we have 12x squared, 89x, and 115. So 12, 89, and 115. This one, we have a difference of perfect squares. 7x times 7x is 49x squared. Our linear terms will cancel. 17 times 17 is 289, and that'll be negative. You could do this out by hand and hit that plus and minus 119. That'll be okay. It'll just take you longer than is strictly necessary. This one, it's the product of perfect squares. So b is 2 times 13, and c is 13 squared. And then going to our final question. This is also a difference of perfect squares. Fortunately, I had to make it a written response. For some reason, it was getting confused when a numeric response answer was 0, but it's x squared minus 12 squared. So again, the expectation is that you could do it quickly like that. Just recognize the pattern, doing it in your head. At worst, if you don't, well, you're just going to take a couple more steps than are strictly necessary. All right. So looking at this, we know that there's the 2 miskeyed I have to fix, and the one that did not have enough space. So that should be 0.6 below the maximum. And that's what we see. Okay. So there's the miskeyed. They're all in RF5. So those will all be manually checked on Monday anyway.